Okay, kids, so we're going to begin with a little video that links a circle to a sine graph. Okay, so as you can see, we have this, oops, wait, stop. Okay, so what you're going to see here is this point traveling. I'm going to go back in this video here so that you can see it. Okay. So what we're going to be graphing is distance above this line here, or angle, basically, uh, that angle to the height that the terminal side is from the x-axis. Okay, so watch, you'll see what I mean. So here's the graph, and here is the angle that we're creating, and the distance, this line here. And it's creating this image here, which is kind of cool. Okay, so we're comparing the angle. We're comparing the angle of this triangle to the height of this side, because remember, in the unit circle, sine is the opposite side over the hypotenuse, and if the hypotenuse is 1, then it's just the hypotenuse, just that height. So let's watch it one more time, just so you can kind of get an idea of what's going on here. Okay? All right, so angle is getting higher and higher and higher. It reaches its highest point right there. Now it's approaching the x-axis again. Oop, now it's going under the x-axis. And it's at its highest point again, or its farthest away point, but in the negative direction, and then it's getting closer and closer and closer to 0 distance again. Okay. Excellent. So let's say that a bug jumps on the second hand of a clock, and it jumps on at this 45-second mark. Okay, I understand that that's a little weird for it to jump on there, but let's say it jumps on there and the second hand is going clockwise because it's a clock, and it's riding along. It's having the ride of its life on this second hand here, and it's and we want to measure its distance or its height above this red line here. Okay, so let's take a look at my graph here. Okay, and I'm gonna oh, this is new for me, so let's see how this goes. All right, so I begin at 0, 0. Okay, and at the 15-second mark, I'm sort of the farthest above my red line. At my 30-second, after 30 seconds, I'm back here. Okay, I'm starting here, 15 seconds, 30 seconds, I'm back here. And after 45 seconds, I'm now the farthest below the line I can be. Okay, and then back to the 45-second mark, that's after a whole minute, or a total of 60 seconds, I'm back here. So the height, or the distance of the bug away from this red line or above the red line looks like that. Okay, so I want you guys to think about something, and you can pause the video. What determines the maximum height of the bug? What length would you say makes that determination? Take a moment to think about it. And we're going to turn the page now. Okay. All right. So I hope that what you said was that it must be the second hand, or this length right here, that's going to determine how high up and how low down the bug goes. All right. Okay. So how is the graph different if the bug jumps on at noon? Well, all right. So here is the bug. Okay, and we'll make legs. And since it's a bug, we're going to call it an insect here. It's got 6 legs. Okay, it is not a spider. Okay, so there's the bug, and the bug is going to go clockwise. So in this case, the bug begins at sort of the farthest distance above the red line, And then after 15 seconds, he is exactly even with the red line. And then at 30 seconds, he's as far below the red line as he could be. And then at 45 seconds, he is right at the red line again. And then after 60 seconds, he is back up to here. Okay. All right. And this looks a little bit different than the other shape, but not really a lot. If we kind of kept going, it would look exactly the same, just kind of like starts at a different place, right? All right. So we've talked about sort of, a real life version where you're talking about a bug, which is, where these things came from. Not really, but so let's actually refer to the unit circle to get the relationship between angle measures and ratios of sides. Okay, remember when we're talking about the unit circle, which is when the radius is 1, the sine of the angle, that ratio is just the y value, right? Here's the x value and here's the y value. Okay, x value, y value, x value, y value, x value, y value. Okay, you remember that because it's the height. Okay, and the x value represents, I'm sorry, the y value represents the height, and so we're talking about the y value. Okay, so when the angle measures 0 degrees, the sine of that angle is 0. Let's go, right, here we go, okay? And when the angle measures 90 degrees, the sine ratio is 1. And when an angle is 180 degrees, or pi radians, then our sine ratio, or our y value, is 0. At 270 degrees, or 3 pi over 2 radians, it is -1. And then at 2 pi, we are back to 0. Okay? And there we are. That is one period of our sine graph. I haven't talked about what periods are yet, and I will in a minute. Okay? That's one period of a sine graph. If we kept going around and around and around the circle, we could go backwards around the circle, and we get that going on. And if we keep going around forwards, we keep going on. All right? Awesome. Oops, wait, go on. Now, what if, pardon me, now the cosine graph is roughly the same thing, except that we are talking about the x-coordinates now, right? So when the angle is 0, our x-coordinate is 1, we start up here, and then when our angle is 90 degrees, or pi over 2 radians, we are at 0, and when we are at 180 degrees, or pi radians, we are down at -1, and here we go, and ta-da, and we get, whoa, so sorry, that was terrible, but I'm not going back. Okay? So that is our cosine graph. Again, sine graph and a cosine graph are really the same thing, it's just that one of them is kind of shifted over. And you can think about why that is, because it's kind of cool that basically, like, if you started here, that would be a sine graph, right? Or if you started there, that would be a sine graph. If you start here, that's a cosine graph. Okay, so I'm going to do some examples where we sort of think about the parent graph, which is what I just showed you. I showed you the parent graph for a sine graph and the parent graph for a cosine graph. And there are a couple of transformations, really basic transformations, that I want to begin talking about. A is the amplitude, and the amplitude could refer to the radius of the circle, the length of the second hand that dictates how far the bug is above that starting line or below that starting line. Okay, we call it the midline. So A is the amplitude, and it tells you like how high up you go or how low down you go in relation to the midline of the graph. Okay, the period is how long it takes for the graph to begin repeating itself. So if we're talking about a clock, think about the period of a clock. I hope that you said that the period for on a clock is 60. It could be 60 minutes or 60 seconds. back to our original example, okay? The period of a parent graph of a cosine or sine is 2 pi because it takes 360 degrees to get back to a repetition of the, the thing that's going on. Okay? So I want to, let's do a couple of examples here. All right? So I'm going to do the first one. The amplitude in this function is 4. Now you might be thinking it's -4, but amplitude is really, it's a distance, so it's kind of an absolute value of this term a here. This negative is just going to flip the graph upside down. It's going to flip the graph over the x-axis because all the y values are becoming negative. But the amplitude is 4. And so that means that the graph is going to go up 4, and it's going to go back to the middle and then down 4. Okay? Now, to find the period of the function, how long does it take for the graph to go through a full cycle? You take the natural period of a sine graph, which is 2 pi, and you divide it by whatever b is, 2 pi over 3. So this graph, rather than taking 2 pi to repeat, it's just going to need to go 2 pi over 3. So I'm going to show you what this graph looks like, right? I'm going to begin at 0, 0 because it's a sine graph, and I'm going to go up 4, and I'm going to go down 4, and then I'm going to stop here. And this point here is going to be 2 pi over 3. This is going to be halfway to the end, which is just pi over 3. All right? And this is going to be halfway between 0 and pi over 3, so that's going to be pi over 6. Okay, and this is going to be, I think, 5 pi over 6. No. This is 2 pi over 6. This is 4 pi over 6. So this is actually pi over 2. Because it's 3 pi over 6. Get it? Alright, so that's 4. And that is -4. Alright? Now, because this graph is flipped, it's actually going to look like that. Because this negative here flips the graph over the y-axis. Okay? So let's look at these other two. If you would like, you can pause the video right now and try to find the amplitude and the period of this cosine graph and see what graph you come up with. So you can go ahead and pause the video. Okay, kids. So for the second example, our amplitude is 1 because the a is 1 there. And our period is the natural period of sine or cosine, 2 pi, divided by b, 2 pi over 5. So now I graph this. I don't care about scale, I just care about these numbers here. So I just graph my picture, and I put in the end of the period is 2 pi over 5. Okay, and the middle of the period is pi over 5. You could find that point because it's halfway between 0 and pi over 5, so that should be pi over 10. Okay, and you can find this point halfway between these two as well. This is 2 pi over 10, and that's 4 pi over 10, so it's going to be 3 pi over 10. Okay, you can do that. Basic arithmetic. Don't be weenies. Okay? And then this last one, 3 sine 2 pi over 3, or 2 over 3 x. So the amplitude is 3, and the period, again, don't be a weenie. 2 pi divided by 2/3. You're all, I can't do that. It was just nonsense. 2 pi divided by 2/3 is the same thing as 2 pi times 3 over 2, and it's just 3 pi. Okay? So I don't want to hear any complaining. So we just sketch our graph. This is a sine graph, so instead of starting on the y-axis, it starts at 0. We get the little loop-de-loop. I want to make sure you guys understand that that this graph continues. I have just graphed one period of this function, but it keeps going over here, and it keeps going over here, and it repeats and repeats and repeats. Okay? So one more thing I want to kind of summarize here is that your is sort of, okay. So sine graph has a domain of all real numbers. Okay, this is important. And a range from and including -1 to 1. Okay, and the period, the general parent graph period, is 2 pi. It's a pain in the neck to get that symbol. Okay, and I'm going to write up here sine parent graph. All right, and it is the same for cosine, for the cosine parent graph. Okay, so domain is all real numbers. Any angle can be an input in these. The output is limited to from -1 to 1, unless of course the amplitude changes, and that basically means that the radius of the circle that this is coming from changes. It becomes bigger or smaller. And the period is 2 pi, unless there is a b, and that transforms the function a little bit. Okay, so I recommend that you maybe watch this video again, just to kind of get this under your belt. Make sure that you take notes. And tomorrow we will do practice graphing problems, and we'll add a little more challenge to these problems.